Rogamos apagar o poner en silencio sus teléfonos celulares para dar inicio a la presentación.
Hello guys, good morning. My friends, our topic is operating system. My team consists of Dahian, riveros, Perez, and Joseph Perez. Me. Introduction. Operating system US are essential components in the field computer. Architecture with an OS computer will not be able to function effectively, and user will have to interact directly with complex hardware components. In the presenters, we will explore a general overview of what operating system the core functions it performs. The most contains operating system wise the real world examples. What is an operating system? An operating system uses is system software that acts and bridges between the computer hardware and the user. Its main purpose is to manage hardware and software requires and to provide a stable everyone works applications generate keypans. Recurse manager the EOS manages the CPU memory strong size and input-output device. User interface provides ways for user interacts with the computer either through graphical interface UI or command lines, interline slide. Process manager organizes and controls tasks and applications ensures that each gets the necessary recurse without conflict. Security and access control protects data and system records from honest access. Brief history of operating system. The history of operating system reflects the evolution of technology. Early days in the 1940 and 1950 computers a hand. No operating system user hands to input instruction device talks, switches of purchase of cards. Batch processing system 1950 and 1900 system just where collects in their batches and executes without user interaction during the processing. Time charting system 1960 and 1970 allowed multiple users to share the recurse of single computer. Improvising effective modern operating systems like Windows, Mac OS, Linux, Android, and iOS offers a multi-stacked graphical interface network capitalized and powerful security features.
Now, let's move on the core functions of the operating systems. Introduction and iOS functions. An operating system performs several crucial tests and keep the computer running effectively. The most important functions include process management, memory management, file system management, device management, and user interface management. Process management. The iOS controls the execution of multiple programs by managing process. Is a task so that different programs can run simultaneously without conflict. This is known the multi-tasks. Memory management. The OS is responsible for the allocation and disallocation memory to different applications. It ensures that programs have enough memory to function properly while avoiding uses like memory leaks or fragmentation. File system managers and device managers organize and control the files of the file systems, which help store and retrieve data effectively. It also manages input and output devices, such as printers, keyboards, and USB drives, ensuring a smooth communication between hardware and software. User interface. Finally, the OS provides a user interface that allows people to interact with the system. This can be a graphical user system like a Windows, Mac, and command line interface like a Linux.
Now, let's explore different types of operating systems and some popular examples. Introduction to OS types. Operating systems are classified based to their functionality and usage. Some common types include single-user, multi-user, real-time, and mobile operating systems. Single-user and multi-user OS. And single-user, like the Windows and Mac OS, is designed for personal use. In contrast, a multi-user OS, like Unix and Linux, allows multiple users to work on the same systems simultaneously, making ideal for servers and business environments. Okay, real-time and mobile OS. Real-time operating systems, RTOS, are used in critical applications, such as medical devices and industrial machines, where immediate responses are required. Meanwhile, mobile operating systems like Android and iOS are optimized for smartphones or tablets, offering the touch-friendly interface and ecosystems. Popular operating systems. The most widely used OS today are: first, Windows, developed by Microsoft. It dominates the PC market. Microsoft, Apple, known for its security and performance. Linux and open source OS using servers, developed and cybersecurity. And Android and iOS, the running mobile operate systems worldwide.
Operating system and artificial intelligence. The integration of artificial intelligence AI into operating system is revolutionary. Then computing performs optimization AI algorithms analyze sensor will have to optimize the CPU, GPU, and NPU, making tasks like voice recognition and image processing faster under board architecture. Cybersecurity AI detects and prevents security errors in the real time, offers provides protections against malware, viruses, and system vulnerabilities. Automated and virtual assistant system integrate a device assistant like Siri, Cortana, and Google Assistant to help users perform tasks and software questions and manage their secures and free. Future occlude as a continuous to advanced operating system will become ever more adapted, predictive, and effective offers a smart computing experiences. In conclusion, operating systems are essential for computing, managing hardware and software, providing user interface and security effective system operated. Externally advanced operating system continue to evolve, offers better performance and security layers. Owens development shakes the future computing, making them a dynamic and vital art of study and innovations. Thank you for your attention.
La pregunta era, what do you consider to be the most important change in operating systems in the last 20 years? Okay, in my opinion, one of the best things that might have happened to operating systems is that you are actually able to find more documentation than in the past. This is one of the things. Second thing, and sometimes it's overlooked, but something that I really consider to be a good thing is when you can find the software in the repositories that you already have. Because in the past, you had to install and point out to different kind of repositories and be like, for example, if you want to install, this is just an example, a DHCP server, you had to install it from the, let's say, Ubuntu repository. But now, and then if you want to install, let's say, iperf, you had to install it from another repository, which is, I don't know, like a university repository, etc., etc. But today, now, on these days at least for me, I have seen that you don't have to add new repositories. You can just install it directly. From the time that I was working in the past, I had to be aware of all that, and also monitoring is actually much better now than before, because now you can actually do some sort of package inspection. Because in my case, because I work with network systems, I like to have, a better a better vision of everything that happens in my network. So I guess that's one of the things. I guess that also you can say that that today is easier to use, say, Linux than it was before, because before in the past only few people were able to use Linux. I hope to that in the next years Linux becomes like some sort of a standard for people, so everyone can start using it and be more familiar with it. What other thing that I might have found interesting? Oh, you know what? Some other technology that I really like, that I think it was invented on the past 20 years, or at least recently. I don't know how recently it was. But one of the technologies I like is zero touch provisioning, or by its by its acronym as ZTP. This thing is a standard in which you can deploy systems using like one single USB drive or something, that you connect that thing and then your system knows where to install it, and then from the beginning. Also, something else that I have seen really interesting is the ability to control most of the systems with something called Puppet. When I was starting to working in the industry, I remember that Puppet was a thing, but it wasn't, as good as today. Meaning that there was no documentation, there was very little explanation on how to use it and why to use it, etc., etc. Same as automation like Ansible, for example. In today's days, I mean, I'm not telling you that whatever has happened to the operating systems. And also one of the other things that I have seen, which is quite interesting, is that operating systems now can work in different CPU architectures. Before, in the past, when you try to put, say, for example, a Linux distribution in a certain type of architecture, it worked wonderfully. But then when you put it into another architecture, there was some sort of issues that you had to solve by working around and putting, new lines of code saying that this program needs to run this way, etc., etc. That is my point of view. I don't know if any of that helps you, but hopefully it's good enough for you. Okay. Finish.